Hello everyone, my name is Vicitra Anak Perempuan Segaran and my matric number is 198839. In this video, I'm going to revise on the method of reduction of order. This method is from chapter 5. So take a look at one example. So the question is solve y double prime minus y equal to exponent of x. So the first step is we need to solve the auxiliary equation to find the YC. So here our corresponding auxiliary equation is m square minus 1 equal to 0, and then we just factor this term to find the root, or otherwise we can use the formula to find the root. So we factor out, so we get m minus 1 and m plus 1 equal to 0. So here we get the root, so our m equal to 1 and minus 1. So our root is 1 and minus 1. So our YC gonna be C1 e power of x and plus C2 e power of minus x. So this is our YC. So the next step is we use the substitution y equal to y1, where actually the y equal to y1 is the solution of corresponding homogeneous equation, where y double prime minus y equal to 0. So here y is the dependent variable, so mean that in step 2 we just use the substitution y equal to v, and then here is one of our term in YC. So here we can choose whether we want to use y equal to v exponent of x or y equal to v exponent of minus x. So here for easier for us to differentiate, so we choose like y equal to v exponent of x. Note that we can use one of these. So we derive this, so we get v exponent x plus v prime exponent x, and then for the second derivative, so we get v exponent x plus v prime exponent x, and then differentiate this part, we get v prime exponent x plus v double prime exponent x. So here we got v prime exponent x, v prime exponent x, so it will become 2v prime exponent x. So our y double prime become v exponent x plus 2v prime exponent x plus v double prime exponent x. So here we get our y prime and y double prime here. So the next step is we need to substitute this into the original equation. We substitute into original equation. Substitute y v prime and we substitute y prime and y double prime into original equation. So here our original equation is y double prime minus y equal to exponent x. So we substitute it, so we get v exponent x plus 2v prime exponent x plus v double prime exponent x, this is our y double prime, minus our y is v exponent x equal to ex. So we simplify this equation. So here we got v exponent x and minus v exponent x, so becomes 0. So we will have v double prime exponent x plus 2v prime exponent x equal to e exponent x. So we can factor out the exponent x here. So it will be v double prime plus 2v prime. Then factor out exponent x equal to exponent x. So here we divide with exponent x. We divide the whole thing with exponent x. So we will get v double prime plus 2v prime equal to 1. So here we get the latest equation. So noted here that this is the second order of equation. So in this reduction of order is mean that we need to reduce the equation into the linear first order equation. So the next step is to reduce the equation. So we use the substitution. We let w equal to v prime and and w prime equal to v double prime. So from our latest equation is v double prime plus 2v prime equal to 1. So we just substitute v double prime with w prime and v prime with w to reduce the equation into linear equation of first order. So we will get w prime plus 2w equal to 1. So here we already reduce our equation into first order linear equation in terms of w. So next we can proceed with the integrating factor method. So we find for the integrating factor first. So our integrating factor is exponent power of integration. Here our p is 2. So exponent of power of integration of 2 dx. So we get exponent 2x. And then the next step is we need to time our integrating factor with the whole thing here. Right, plus 2w. Then we time mu x with 1. So our mu x is exponent of 2x times w prime plus 2w equal to e 2x, and then time with 1. And then here note that the rule from the integrating factor method is when we time this thing, mu time with dy over dx plus pxy actually equal to d over dx of integrating factor and y. But here our variable is not y, our variable is actually w. So here is actually in this case our y is w. The variable in this case is w, not y. So we just use the rule from the integrating factor here. So here we get d over dx of our integrating factor is exponent of 2x, and then our variable is w. Then here is equal to exponent of 2x. So to solve this, we integrate both sides. So we get exponent 2x w equal to integration of e to x with respect to dx. Then we solve this, we get exponent of 2x w equal to 1 over 2 exponent of 2x, and then plus, don't forget the constant here, we let the constant is a1, and then we define for w equal to, we just divide everything with exponent of 2x, so we get 1 over 2. Here 1 over 2, and then we get here divide by exponent of 2x, so we get w equal to 1 over 2 plus a1 the exponent, and then e power of minus 2x. Here we get our w equal to 1 over 2 plus a1 the constant, and then exponent of minus 2x. So the next step is we need to substitute back the w equal to v prime. So we get v prime equal to 1 over 2 plus a1 exponent of minus 2x. And then we need to find for v. To find for v, we just integrate the v prime. Then we get v prime equal to integration of v equal to integration of v prime, where our v prime is 1 over 2 plus a1 e power of minus 2x with respect to x. Then we get v equal to 1 over 2x plus a1 plus a1. Here we get, so we get actually, here we get exponent of minus 2x, and then time is minus 1 over 2, and then plus the constant is a2. Then actually we get 1 over 2x, and then here minus 1 over 2 a1 exponent of minus 2x plus a2. Here is the constant, so actually we can change minus 1 over 2 a1 into the third constant. So our v become 1 over 2x plus a3 exponent of minus 2x plus a2. So here we get our v. But this is not our final solution, because we want to, our final solution should be y equal to something. So next step is we just substitute the v here into the y equal to v exponent x. So we just substitute our v, so our v just now is 1 over 2x over 2x plus a3 exponent of minus 2x, then plus a2, and then here time is exponent x. So we simplify this, we get 1 over 2x exponent x plus a3 exponent of minus x plus a2 exponent of x. So here we get our final answer. So our final answer is y equal to 1 over 2x exponent of x plus a3 is the constant, exponent of minus x plus a2 also constant, exponent of x. So here we get our final solution. So that's all from me. Thank you.